Hello again, welcome to Structural Analysis Made Fun and Easy. So today we're looking at this Chapter 2 Problem 2.9, Pin Jointed Frameworks. Pin jointed frameworks are symmetrically eluded. So it's like a diagonal little mini structure of 1, 2, 3, 4, 5 members. This is Problems 2.9. From linear analysis of structures, as per the other videos I've just been doing by T.R. Gravesmith, copywriter, to T.R. Gravesmith and Ellis Horwood, publishers. So we've got a pinned joint at A and a pinned roller at B, and then three sections, let's say 3 meters, 3 meters, 3 meters, and then the height is also 3 meters. So this helps, as you see already, looking at this immediately. So if you look at DB, that's going to be at 45 degrees because that's 3 meters and 3 meters. And then the middle section, that's like 3 meters. So BC and AD, not sure exactly what that angle is without calculating it, but that's 3 meters by 6. Yeah, so. And then there's a 40 kilonewton point load at C, at pin C. The number of joints is 4, the number of members is 5. Yeah, so this is Chapter 2, Statically Determinate Frameworks, Problem 2.9. So page 1 of 2. So just quickly did the number. This is the forces reaction. Oh yeah, the force reactions notation and member numbers notation. So we've got, because we've got a pin at A, we've got RA, then vertical reaction RA, horizontal reaction HA at pin joint A, we've got member AC, member CD, member BD. So I just numbered it A, B, C, D. So AC, CD, BD, AD, BC, 40 kilonewtons down, RB and RA vertical, HA horizontal, no horizontal reaction at B. So that gets us set up. That sets up the problem for us. Then, so step 1 is external equilibrium. We've got take horizontal equilibrium. HA equals 0. Check. No external horizontal forces, so there's no support reactions. There is no HA reaction because B. If there was a pin at B, then we could have HB and HA holding it in, but B is free to move in X, so that probably moves over a bit in reality. If you built a little model of the structure, this B would move from left to right under the load. So then take vertical equilibrium, RA plus RB minus 40. Let's say RA and RB, yeah, assuming RA and RB are vertical upwards, then RA plus RB minus 40 equals 0. Say that's equation 1, so we don't know what RA and RB are at this stage, only that. So RA plus RB equals 40 if we rearrange the equation. So we need to take moments about A to determine RB. And remember that clockwise is a negative and anti-clockwise is positive. So go back to that diagram quickly. So if we take moments about A, got 40 times 3 plus, minus 40 times 3 because it's clockwise, that's 120. And then that's the only external force, plus 9 times RB, that's positive because it's anti-clockwise, equals 0. Call that equation 2. Rearrange, solve, calculate. So minus 120 plus 9RB equals 0. 9RB equals 120. RB equals 120 divided by 9 equals 13.3333 kilonewtons. Call that equation 2 result. So now, now we've got to substitute equation 2R back into equation 1. RA plus RB equals 40. RA equals 40 minus 13.333. So RA equals 26.667. Yeah, that's correct. So just quick check. Say 40 minus 13, that's 27. and then so 27 minus 0.333 is 26.6667 kilonewtons. So there's a little diagram of the this is the results of the external equilibrium. So HA equals 0, RA equals 26.6667, RB equals 13.333 kilonewtons, and with a downforce of 40 at C. So RA plus RB, let's do a quick double check. RA plus RB equals 40, 26.6667 plus 13.333 equals 40, HA equals 0. Right, that's done, so that's checked. So if we've done that, that looks right. As you can see, it's slightly, because the load is slightly towards A rather than B, so it's higher reaction on A. Makes sense. So now, unless you're really good at trigonometry or you've got lots of experience, I'm not sure what the member angles are. So I've got to quickly confirm angles for equilibrium of joints. Yeah. So for exam technique, may be obvious it is an angle by inspection. So if you know that, or if you're very well experienced, you probably know that the angle for if the opposite side is 3. If the opposite side is 3 and the other side is 6, then that's 3 over 6. So you'd know what the angle is. Check if you've got time. If you want to double check it, you've got to check if you've got time in the exam. Use your own judgment as to if it's required. If you don't know it is, you'll have to do it. If you guess it, then it's at your own risk, and then if you know it, you're safe and sound. So length AB2 is 6. I call that. Oh, say this point is called B2. That's not B. That little dot's not B. That's B2. I called it. AB2 is 6. H equals 3. Remember AD is between A and D. So tan beta equals 3 over 6 equals 0.5. Beta equals arctan 0.5 equals 26.57. So we can just double check the length of AD just out of interest. AD equals, one way of doing it is the AD is the square root of AB squared plus AB2 squared, that should be, plus AD squared equals 36 squared plus 3 squared square root of 45 is 6.708. So for member AC, we just double check it. I know that we all know that is 45 because that's 3 and the opposite side is 3 and the adjacent side is 3. So since x equals h equals 3 by inspection, alpha equals 45 degrees. Yeah, we can see that. Check for this video in case you wanted to see if it proved if alpha wasn't 45. So tan alpha equals 3 over 3 equals 1. Alpha equals arctan 1 equals 45. It was obvious, but it was just to check to avoid any mistakes. If say it was 49 degrees, yeah, or something like that. So now that gives us the angle for beta is 26.57. The angle for alpha equals 45. So now we do step 3, equilibrium of joints. We're starting at joint B as we got reaction RB, and there's only 2 unknowns with 2 equations at joint B. There's BD and BC, which we don't know. Start at joint B. Yeah, we've got 2 reactions, only 2 unknowns, 2 equations. We've got 2 equations of equilibrium: horizontal equilibrium, vertical equilibrium. We should be able to find it. So say BD is in compression, just to get us started. Say BC is in tension, just by inspection. So because if BD is compression coming in, if I'm just guessing, so you got RB is up, so probably BD vertical is down. So then we say BD is in compression. We got no HB, that's 3 in X. So then 2 separate to simplify. Yeah. So what I've done, just to try and make it clearer, is separate to simplify and illustrate. So this is the pin. That's all pin. I've drawn out bit joint pin B 3 times. So pin B has RB reaction, then pin B has BD coming into it. BD has horizontal component HBD, a vertical component VBD. So HBD is left to right, VBD is top to bottom. That's opposite to RB, of course, because it's got to be balancing RB. So either VBC or VBD's got to be down, or both of them could be down. And then HBC, so BC the angle is 26.57, VBC is up, HBC is right to left, yeah. So that has all got to be in equilibrium. Those forces have got to be at equilibrium. For example, in vertical direction, RB plus VBC plus VBD must equal 0. And for horizontal, we can see HBC plus HBD must equal 0 because there's no external forces. So it's quite helpful just to draw out that little diagram with the vectors on it, because then you can visualize it instantly. So let's start with horizontal equilibrium. H equals 0, so that's external. So that means that the horizontal components of HBC and HBD must be equal to 0 if both components of HBC and HBC are positive, say. Then for horizontal equilibrium, HBC plus HBD plus 0, that should be HB to 0 equals 0. So then for HBC equals minus HBD, so HBC is opposite to HBD. That's obvious, isn't it, from the little diagram? So HBC must be equal but opposite to HBD. So HBD is opposite to HBD. HBD is compression. Let's say I said HBD compression. So BD is compression. So HBD is from left to right, and BC is tension. So HBC is tension from right to left. So let's work out the horizontal components of BD and BC so we can balance them. So starting with BC, done another little diagram there. HBC, VBC is 3 meters high. HBC, the horizontal length is 6. So the angle is 26.57 BCC. So no joint at joint, that's A2. So cos 26.57 equals HBC over BC. So BC equals HBC over cos 26.57. Cos 26.57 equals 0.894444. So therefore BC equals HBC over 0.89444 equals 1.118 HBC. So result 1 is 0, 1. Result 1, BC, equals 1.118 HBC. So that we need that because we're working out what are the horizontal components of BC and BD. So sorry, I've done that wrong. That should be D. A, B, C. So this one is CD. BD. Sorry, this is BD, the 45-degree one. Internal angle B2 equals 45. So cos 45 equals HBD over BD. So no, because it's 45 degrees on both sides. Sin 45 equals HBC over BC. So cos 45 equals 0.707 equals sin 45. HBC is 0.707 BC. So result 2. Sorry, that's BD. HBD equals 0.707 BD. So sorry, I'm going to correct that in the next video. It's a bit of luck actually, because this final sheet 10, that should be BD, so I'm going to correct that. Because this video is getting a bit long, could you please tune in to the next video for part 2 when I'll complete the solution, and I'm going to correct page 10, because this is this page 9 is correct, so start at joint 9, we got, this is BC, so BC equals 1.118 HBC by trigonometry, and then this sheet 10, this should be BD, not a BC again. I've written it there, VBD. I've made two mistakes. It should be HBD equals 0.707 BD. Result 2, HBD equals 0.9. So please like and subscribe to this video. Please like the video. Please subscribe to the channel so I can make more videos. I did find myself also though, once you start doing these, it's getting a lot easier. Well, especially checking over them is really easy as well. It's just when you haven't done some, and you know, I don't know if other people have the same problem with some concentration problems and stuff. So if you could like and subscribe to the channel, that would be great. Thanks. Hopefully I'll see you in the next video. Oh, if you have any comments, please leave it, let it go. Leave a comment in the comments box, or email me, and I'll get back to you as soon as possible. Thanks. Hopefully you found it useful as well. Thanks. See you in the next vid.